Transformations of sine and cosine. The graph of a sine or cosine wave can be transformed by either shifting, stretching, shrinking, or reflection. The elementary transformations of a sine and cosine wave are captured in function notation as follows. Shifting up or down would be sine of x plus k or cosine x plus k. Shifting left or right is sine of x minus h or cosine of x minus h. Distortion, so stretching or shrinking vertically is a times sine x or a times cosine x. Stretching or shrinking horizontally is sine of bx or cosine of bx. Reflection over the x-axis is negative sine x or negative cosine x. Reflection over the y-axis is sine of negative x or cosine of negative x. Shifting the graph of a function sine x up or down is given by sine x plus k and is called a vertical translation. If k is greater than 0, then the graph of sine x shifts up k units. If k is less than 0, then the graph of f of x shifts down k units. So consider f of x equals sine x here in red, and two of its translations, g of x equals sine x plus 2, and h of x equals sine x minus 3. The graph g is the result when sine x moves up 2 units. The graph h is the result when sine x moves down 3 units. The grid looks like an ice cube tray. Move the 4 pieces from the left to fill 4 small rectangles strategically to create these functions. So g of x equals sine x plus 2. Well, sine x is here, like that, then decreasing concave down, decreasing concave up, and then increasing concave up. So for sine x plus 2, we take each piece and move it up 2 units, like that. G of x equals sine x plus 2. For h of x equals cosine x minus 1, regular cosine x is up here, like this, with the y-intercept at 0, 1. So cosine x minus 1 would be taking this graph and then moving it down 1 unit, so that it looks like that. Shifting the graph of a cosine wave left or right is given by cosine of x minus h and is called a horizontal translation. If h is greater than 0, then the graph of cosine x minus h shifts right h units. If h is less than 0, then the graph of cosine x minus h shifts left h units. So here in red we have f of x equals cosine x. In blue we have cosine of x minus pi over 4. So we've shifted to the right by pi over 4 units. So if h is positive, it will look like x minus h. If you're moving to the left and h is negative, it'll turn into a plus sign because that's x minus negative pi over 2. So that becomes x plus pi over 2. So here you can see we've moved to the left by pi over 2 units. Use the function f of x equals cosine x for each problem below. Write a rule or formula for the new function g after the given translation. Shift the blue graph left or right as described. Write pi over 2 units to create. Alright, so we move it to the right, pi over 2 units. That will be g of x equals cosine x minus h. And if we're moving to the right, h is positive, so this remains a negative sign, pi over 2. And then we just take this and we move it over pi over 2 units so that it's right there. And there we go. Now let's move it back to where it goes, starting position. Now we have left negative pi units. So h is negative pi. So g of x is going to equal cosine of x minus negative pi. And minus negative is going to turn into a plus sign. So we have cosine of x plus pi. So that moves it to the left pi units, which is 2 blocks. So it looks like that. And there we go. Now let's move this back to the starting position. All right, now we're going to move it left negative pi over 4. So this is going to be the function equals cosine of x minus negative pi over 4. So that becomes plus pi over 4. And so pi over 4 is half of 1 unit. So we move right there. Okay, there we go. Now we just move it back to the starting position. We're going to move right 3 pi over 4 units. So that's going to be cosine of x minus 3 pi over 4, since h is positive. Now we're moving to the right 3/4 pi. So pi is 2 boxes. So 3/4 pi will be 1.5 boxes. So we move this 1.5 right to 3 pi over 4. And there we go.